Is everything working fine? Yeah. Welcome back to another video of SpeakCode, wherein we are going to uncover our next topic in Python, which is operators. Let us go from beginner to advanced level of these operators usage in Python. So before moving on to that, do you actually remember the previous topics that we were discussing in our session? Still, let us have a recap of what we have discussed till now. Do you know that Python actually speaks? Yeah, Python uses print statements in order to interact with the user, and this print statement is written as this print function and the strings and the argument that we are going to print to the terminal. Now let us move on to variables. Now these variables are defined as containers which store data, and further this data is classified based on its data type into primitive data types and non-primitive data types. Whereas primitive data types are further classified as int, float, complex, boolean, and strings. And these non-primitive data types are list, tuple, set, and dictionary. Here we have several variables storing data of different types, which is string and an integer. Now, this can be printed using format as string, that is f string, which is f prefixed before a string. So here name variable is directly replaced with Alex and age is directly replaced with 25. This is the advantage of f string, and everything in Python is an object because Python treats every variable, function, and class which are we are going to discuss in further classes as an object. And moving on to typecasting, wherein we convert a particular data type to other data type explicitly. Let us observe this through an example. Here we have a variable named x storing 10, and we have similar variable x storing Python, which is string. Now what we are observing here, same variable x was storing an integer, then suddenly it is storing a string. Here Python changes its data type from int to string, which is happening dynamically. So it is called dynamic typing. Whereas when we explicitly convert a data type, it is called typecasting. Here, current status of num string is 5 as in string format, whereas num int, here num int stores the integer value of num string. What is happening right here? Num string is an string. Here we are applying int function to convert string to an integer. Then later on we are adding 10 so that we can check whether the data type of num int is integer or not. Now what should be the output of these? Integer 5 plus 10, which is going to be 15. Then here comes the concept of multiple assignments. In Python, we can assign multiple values within a line. Enter several variables that we are going to use with proper commas, and then the values that we are going to assign to respective variables, and then print them. A is going to be storing 1, B is going to be storing 2, and then C is going to store 3, which is printed using print statement. Let us check the output. As we can see here, output is 15 as expected, and variables were assigned correctly. Today let us understand operations. Think operations as how Python thinks and interact with data. Every calculation, comparison, and decision starts here. So it is very much important to understand what are operators actually. Operators are symbols or keywords that tells Python to perform a specific task on one or more operands. Here we have several operations: arithmetic, assignment, comparison, logical, bitwise, membership, identity, and some special operations. So let us discuss one by one so that we build a good understanding. Let me open my collab. As we have 7 main operations in Python, it is very much important to understand the purpose of each and every operation. So let us start with arithmetic operators. Or these arithmetic operations are helpful to perform basic mathematical operations such as addition, subtraction, multiplication, division, floor division, modulus, and exponential. You might have already explored all of these basic math. You might have introduced to a new word called floor division. What does this do? Let us see this output. By seeing this output, here when you see division gives us output as entire value of 10 divided by 3, whereas float division just gives the integer value before decimal point. Here where lies the key difference between division and float division. Division gives us the entire value of divided number, whereas float division just gives us the integral part before the decimal value, and modulus leaves a reminder, and whereas exponential gives us the value of a to the power b. Let us move on to assignment operations. There are five different variants of assignment operations, which includes regular equals to, less equals to, minus equals to, asterisk equals to, and slash equals to. Now, it is very much important to understand what is the purpose of these assignment operations. So let us move on to collab. You can observe assignment operations are usually used to assign values to variables, but in different ways. Let me show you this through some examples. Initially, I am assigning a value 10 to A using regular equals to operator. Now, I am introducing a new operation which is plus equals to. What does this specify? You will be understanding this operation better if I write the other form of this. Observe this nicely. This can also be written as A equals to A plus 1. What are we doing right here? We are taking the current value of A and incrementing it with 1, which can be also written using this assignment operation plus equals to. We are incrementing the current value of A by 1 and assigning it to the same variable A. Here this both serves the same purpose of assigning the incremented value of A, but differ in their operations. Plus equals to is performed faster in compilation rather than A equals to A plus 1. So whenever you are incrementing values, use plus equals to or decrementing minus equals to, which can also be written as A equals to A minus 1, incrementing the current value by 1. Similarly, you can write this as A equals to A into 2. Now, let us see the outputs of these using actual assignment operations, right? Let me erase these representations and understand this program. Here you can see the output. Current value of A is 10, whereas the value of A of incrementing by 1 is 11. The value of A after decrementing by 1 is 10 again. Then multiplying it with 2 becomes 20. This is the basic concept of assignment operation. So now let us move on to next operation, which is comparison or relational operation. There are total 6 variants of these comparison operations, which is double equals to, which checks the equality of values, whereas not equals to, which rejects the equality of values, and greater than, less than, greater than or equals to, and less than or equals to. These are the basic comparational operations. Let us have some examples so that you build better understanding. Here you can see the example. Currently value of x is 5 and y is 10. So what are we performing right here? Comparison operation, which is saying that x is greater than y. Is that true? 5 is greater than 10? No. So I want you to expect the output of this program, which gives us false. Similarly, let us decode this x equals to y. Here equals to operation refers to the comparison between two values. We check whether the two values are equal or not. Here it says that x is equals to y, where it is false. So if ALSE false again, then x is not equals to y. Is that true? Yeah, absolutely. X is not equals to y. So it gives us output as 2. Now let us come back here after discussing about logical operations. What are logical operations? Logical operations include and, or, and not. Let us check the purpose of these logical operations. Here, logical operations are used to combine conditions to our current program. How is that possible? Check here. Here I am using our current operator, which was used right here, to check whether the two values are equal or not, and this gives us output as false, right? Here when we apply not statement to this, it gives us the value opposite to the current, which is not of true is, sorry, not of false is true. So the output will be true. is equals to true. If you observe the second example here, it combines two operations. A logical operation combines two operations. Here we are checking whether x is less than or equals to y or not. X is less than or equals to y. 5 is less than or equals to 10, which is true. So this gives us output as true. And applying logical and including x greater than 10, which is also true because 10 is greater than 0. So this gives us output as true. Now combining true and true gives us the value true. I think you have studied logical operations in your 10th or intermediate standards, so it will be easy for you to apply this here. Now let us tally our outputs: false, false, true, true, and true. Now moving on to next operation, which is bitwise operations, wherein logic goes down to bits level. These bitwise operations allows us to control data bit by bit. As you can see, there are several bitwise operators: and, or, XOR, not, left shift, and right shift. And one if both bits are 1. I will explain this. Or 1 if either bit is 1. That is true if either of the bit is true, right? Similarly, we have XOR, not, left shift, and right shift. Let us go with this example. 5 is assigned to X and 3 is assigned to Y. If we imagine bit number of 5, 0, 1, 0, 1, whereas 3 is 00, 11. When you apply AND, what will be the output? Like output bit number. 1 and 1 gives us output as 1, and then 0 and 1 gives us output as 0, and then 1 and 0, 0, and then 0 and 0 gives us 0. Converting these binary number to decimal gives us output as 1. So when you do bitwise operation between two operands, output will be given as decimal, right? X or Y. Applying X or Y, true and true gives us output as true. Either of value is true, output will be true. So 0 and 1 gives us output as 1. 1 and 0, 1. 0 and 0 gives us output as 0. Now here we need to convert this into decimal. That is 2 to the power of 2 plus 2 to the power of 1 plus 2 to the power of 0. That is 4 plus 2 plus 1, which is equals to 7, right? Similarly, experiment this with XOR gate. Now let's check whether we are getting the same output or not. 1, 7, and 6. That's what we got. We can also explore these other operations like left shift and right shift. Although we don't use much bitwise operations in our programming, but there are some rare cases we need to use them. Let's move to the next topic: membership operations. In operation and not in. What in refers to? It checks whether an element is present inside the container or not. Let's go with this example. Print P in Python. What does this refers? In operation checks whether the string, that is P character, is present in the right side string, that is RHS value, that is Python. As we see, P in here, first character, matches to P. It returns true. Yeah, let us do some examples. And similarly, not in refers to not having element in particular container or variable. Here we are having same example: Python P in name. Name refers to Python, right? What should be the output? Yeah, it should be true because P is present in Python, right? Z not in name. Do we have any Z in Python? I don't see any Z. So what will be the output? It's true. Both the outputs should be true, right? We are having a list 1, 2, 3 and a list B 1, 2, 3. Both are same, and we are using. Okay, first let us finalize the upper one. Yeah, both the outputs are true, right? Moving on to identity operations, we have is and is not. What does this refers? Understand this with this example. We have a list. This represent a list. I will explain what is a list clearly in further slides. So for now, just think it as a container which stores multiple values, right? Now we are assigning this list to A and a similar list to B, that is the values which A and B are storing are equal, right? So this equals to operators checks equals to. I think you remember this we discussed in here where comparison or relational operators. So we use these to check whether both the values are equal or not, right? But whereas is operator is used to check whether both variables are pointing to same memory location. A is different variable and B is different variable. So is A is B? No, because A is located in different memory location and B is located in different memory location. Both cannot be same. So it returns output as false, whereas A equals to B returns true. Let's check this. Yeah, false and true. Now what I will do is I'll just comment this out. Now I assign value A to B. Now let's check what will be the output. Do you have any guesses? Let's check. Yeah. Why is it giving true? A points to this list, whereas B points to A. That means B is indirectly pointing towards this list, right? So where A is B returns us value true. I think you understood difference between equals to and is operator. This is relational operator, whereas this is identity operator. Let's also experiment this. Print A is not B. It is saying that A is not equals to B. Is it true? No, because B points to A, where A and B are equal in their memory location. So it returns false. You can try experimenting all other operations. Let me go with this second one. Convert total minutes into hours and remaining minutes. Given an input as total minutes, we just need to convert that into hours and the remaining minutes. But if you think, if I gave you 75 minutes, when I give you 75 minutes, it indicates that 1 hour and 15 minutes. How am I saying that? You put that 60 minutes of an hour because 1 hour equals to 60 minutes, and the additional minutes in 75 minutes is 15 minutes. So 60 plus 15 equals to 75, right? Now 1 hour is equals to 60 minutes plus 15 minutes. 1 hour 15 minutes. This should be the output. This is the base logic we need to think. Now when we move on to problem solving, first thing that we are going to do, it is taking input from user. So in Python, we usually take input using keyword input. I am storing the input given by the user in variable time and taking input using this input keyword. I want my program to ask user to give me input time. So now user enters the time. I have got the time. But whenever user enters something, input function by default assigns it data type as string. So we don't want string as our inputs. I just need to convert this into an integer so that we have an integer value, hours and the leftover minutes, right? Here what we are going to do, we need the remaining time and the actual hours that we are left with. So these both can be calculated using two different arithmetic operators. Remaining time can be calculated using the modulus operator, which gives us the remainder, which gives us remaining time. When I want time in hours, I just go divide our current time with 60, and then when I want minutes, I just have remainder time in minutes. So then print, it should give us output. Now let me enter 75 minutes. It should give us output as 1 hour and 15 minutes. I hope you understood this example. Stop right here and do remaining problems before getting into next concept. You may till here and still wonder about how Python make decisions using control statements. Just click on this. I will meet you on the other side of this video. Till then, signing out.
YouTube video. Sir. Congratulations. What's next? Do you need help with editing, uploading, or something else?